Okay, this tutorial will cover interface. Again, this is also a class relationship. So let me begin with inheritance and then a bit of a abstract class. Then I will introduce interface, or the reason why we have to use interface. So we have employee class, and then one data field called name and setters and getters. Okay, try to use the same example of students and instructor. This time I will focus on instructor. So we have employee class with one data field. Then we are going to extend employee class as instructor. So employee class becomes superclass of instructor. For this particular instructor class, I will make it as an abstract class. Because I'm going to have two subclasses of instructor. One I will call it as a part-time instructor, and the other one call it as a superclass instructor. The other one is a full-time instructor. So first one, part-time instructor. I will just say part-time. Just normal class. For now, no data field and then no methods in the constructor. Here, full-time. So this case, part-time, full-time classes through superclass instructor, we can extend from employee class. So let's look at interface. Interface is very similar to inheritance. It's an extension of a relationship between two classes, but it models weak is an extension of relationships. The first definition gives you a reason why we have to use inheritance. Sometimes second class we have to define as an interface, and so on. Another reason why we want to use interface is to define common behavior of classes. Okay. So first one is weak. Let me explain here. Let's say instructor will get paid either is monthly for full time, or weekly, or 2 weeks, bi-weekly for part time, based on hourly rates. So let's say payment class, we have one method called how to pay. I will just make it simple as a string. Seems pretty okay. So let's say we have a binary relationship. Can we say it's an extension of payments? This is not allowed in object-oriented programming, like a C++ or Java. This is what we call it as a multiple inheritance. Again, instructor cannot have two superclasses. So if we pick one, which one is a weak, is an extension of class between instructor, employee, or instructor and payments. It seems to me that the instructor and payment is a weak relationship between that. If that's the case, we can focus on common behavior. It means no matter what, part-time, full-time instructor will get paid. So we will focus on behavior. In this case, we're going to focus on methods. So if you look at here, payments. Normally what we'll do is, instead of making it as a superclass, we can change to interface. We use the symbol, looks like less than or greater than inside. Name of the interface, we use adjective instead of noun. So instead of saying payments, we will say payable. Here, data field, normally we have only constants. Okay. For now, I will just say constants only with the comments. Similar to abstract class, but in interface, we can have only abstract methods. It means we cannot have a concrete method like how to pay. We have to change in italic. That actually means that that is abstract methods. Again, looks quite the same, but those are all italic. So how do you visualize the weak relationship between instructor and payable interface? We use dashed line. Instead of using solid line, we use a dashed line, okay? So relationship between the instructor payable is dashed line, okay? It seems not quite clear, but it is dashed line between instructor and payable interface. Okay, that's how you draw UML class diagram. Include inheritance between employee, instructor, and also part-time, full-time. Also, you can draw the interface between instructor and payable. We call it as a instructor implement payable interface. Okay, that's the abstract class. So let me just make it clear. Okay, let's look at the demonstration. Okay. For now, let me create employee class. Let me hide it. So we have one property called name. Again, I'm going to have a getter and setter. Maybe toString as well. Okay. Next one, I will go to instructor. Okay. Let me create two subclasses. This one part-time, and then full-time. So let me focus on inheritance. Okay. So instructor extend employee. Let's look at part-time and full-time. Okay. Part-time extend instructor. Again, full-time extend instructor. So that's the part of inheritance. So here we are going to look at abstract class. Let's say instructor is abstract class. Okay. Now we are going to look at interface. Okay. So let's focus on payable. Just naming convention. We name it as adjective rather than a noun. So here, let me focus on interface. Then I'm going to explain multiple inheritance, why that's going to be not allowed. So let me just put one comment. Here we declare as a class payable. Okay, let's see whether multiple inheritance is allowed or not. So it means that you go back to instructor. Can I add one more class with a comma? Payable. Here it says that or implement expected. Okay. So we are now allowed to list more than one class. So delete it. So that is now allowed. For interface, we actually declare as an interface instead of saying class. So let me just explain. So here, say payable can be a support class of instructor. So we can change the interface that represent week is an extension of a relationship between instructor and payable interface. Okay. So here we are using implement payable, name of the interface, rather than saying extends. That refers to inheritance between two classes. Interface, we say implements. Okay. And then with this interface, we can have a data field or properties, of course, but we can have only constants. And these constants, we must have a public, static, of course constant we declare as a final. So it will be look like this. Okay, sorry, should be public, static final, double. Let's say pay late 20%. So let me check. Okay, I miss. Oh, okay, that should be public static final. Okay, final should be in front of data type. And then, sorry, I'm missing equal sign. Make it clear 0.20, and that should be 20%. Okay, simple mistake. And then interface, we can have only abstract methods. We cannot have a non-abstract method. Everything should be declared as public. So public abstract, let's say return time string, how to pay. For example, hourly or monthly. Okay, that's the interface. We just finished the implementation. So we have an interface. Part-time extend instructor, that's okay, because the instructor implement a payable interface. So if you look at here, there's nothing to implement. But if you look at here, part-time, it says that must implement abstract methods, which belongs to payable interface. Because the instructor itself is abstract, so we don't have to implement it. But part-time is not a non-abstract class, so we have to implement it here. Pay by hourly. Sorry, I should change to return. Return and pay by hourly. Okay, that's the part-time. And full-time, again, same thing. We need to implement abstract methods. It belongs to payable interface. Return string data type, pay by monthly. Okay, pretty much done. Okay, now we are going back to main applications. So here with the main methods, let me construct two objects, one based on part-time, one based on full-time. Instead of using object array, I will use array of instructors. I'm going to construct the two objects without object name, say just new part-time. This is what we call as an anonymous object without names. New full-time. Two objects will be stored to instructors array. Okay, so that array has two objects. because it's an array, let me process with a for loop. Array dot length I++. Here we need to go through if conditions. Okay, we need to identify whether it's a part-time object or full-time object. We have one operator called instance of. Capital O is not correct, it's a lowercase o. And then part-time. So instance of will identify whether our object stored in instructors array is instance of part-time or full-time. Okay. So here I will say part-time. Typecasting we have to do because the object itself can be a part-time object or it can be a full-time object. Okay. So here missing parentheses. Okay. So let's say typecasting, then refers to how to pay. I think I'm missing one here. Okay. Second object, we are looking at full-time objects. So if the object stored in instructors array happen to be full-time, then I will process as a full-time. Okay. This way we are going to get two outputs. One is based on object type. It will say how to pay, hourly or monthly. Okay. Again, hourly first object, and then second object is full-time. Again, so pay by monthly. Don't forget, a new instructor is now allowed because instructor is abstract class. Abstract class, you cannot construct objects. Don't worry, I will explain later on when I deal with abstract class in depth. Let's see what else I can do. Again, instance of, let me explain first. Again, instance of operator. Test if object is of a given type. In this case, it's a part-time or full-time class type. Okay, here let me just name objects. Part-time as PT, new and part-time, so that we can print what's inside the PT and then full-time object. So let me name Part-time instructor is John. Full-time. I will say Jenny. Again, I will replace them, PT, and then full-time. Then line number 31, maybe 32 now. So we can print part-time object dot toString, and then full-time object and dot and toString, so we can see name of the instructor. Let's see. So first one pay by hourly, and then John is part-time, monthly, and Jen is full-time. Okay, this might be more easier. So let me go back to illustrations. Here we had inheritance. Also we had the interface. Please look at the rotations. And then it's not a solid line, okay? So we have two different things, okay? That's all. Thank you.